Good evening and welcome to Chicago Students Dominate Math. I'm your host today. My name is Eric Hendricks. I'm a school teacher at Providence St. Mel School. This is a live call-in interactive show brought to you through the facilities of CAN TV. The number here, 312-738-1060. I'd like you to call in and I'd like to entertain all of the questions that maybe you have in your math class. I'll do the best that I can to answer whatever questions you have and serve as your math tutor for the evening. The way I like to run the show is with the call-ins. I'd like you to call in. The participation really makes the show move quickly. In the event that we don't have calls, which unfortunately happens from time to time, what I do is I bring in certain topics that I would like to discuss. And today's topic is actually, final exams are coming up, and what I'd like to do is review some of the topics that our students at Providence St. Mel are covering in our pre-calculus honors class. And I'm completely prepared to stop what I'm doing and work with whatever topics you find interesting or whatever topics you are studying in your class. I feel comfortable talking about topics ranging from algebra, in geometry, pre-calculus, AP calculus, and even some statistics. We're going to talk about some statistics today. So, again, call in and we'll entertain whatever questions you have. In the meantime, what I'd like to do is, like I said earlier, I'd like to review some of the topics that our pre-calculus students are going to be covering. The topics that we're going to begin with are statistical in nature. All right, so let's just jump into it. All right, so we're going to be talking about beginning. Our students have to have an understanding of what we call frequency tables. And I took some notes earlier, and we're going to move to page 639. Now, this page 639 is coming from an advanced math book. This is not our pre-calculus book, but our advanced math book, okay? And what I'd like to do is, we've got some data here. Let's use the data that is right in this section right here, okay? So oftentimes when you're working with statistics, what you'll discover is you're really just either interpreting or you're trying to get a feel on what data is telling you, okay? You're trying to get an understanding of tendencies, trends, all based on an amount of data. And that's what we're doing here. We've got, let's say these are some scores. This is called a stem leaf diagram. And let's say you got to score 32, you've got to score 35. And what we're doing is we're organizing these scores. So you've got a score that's, in fact, I think what we'll do is this data here is a little bit more organized. Let's switch charts and let's look at this data instead. So you still got that score 32 and 35, but this section here is really, it's the same thing as what I had over there, but it's a little bit more organized. So let's say that we want to take this data here and produce what's called a frequency table. In other words, we want to get a real good idea of what this data here looks like in more of a chart format. And I sort of created a template. Let's say if I can put it off to the side here, maybe you can see both. I've got a little template here, and I'm going to try to organize this data here in terms of what we call a frequency table. Let's move this off to the side just a bit. All right. Okay, so what we'd like to our students to be able to see here is how frequently did you experience the score between 30 and 39? How frequently within this data here did you experience a score between 30 and 39? I'm intentionally using the word frequently because oftentimes when we use the word frequently, it sort of can be exchanged with the number or with the expression frequency. So you see the scores between 30 and 39 two times. And then this cumulative score represents a total number of scores that you have taken into consideration up to that point. So for this particular chart, our cumulative score would be 2. All right, we're just sort of adding the total number of scores that we have taken into consideration in this cumulative column. All right, so how many scores are in between 40 and 49? All right, so all you have to do is just observe. You've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13 total scores that are the 13 people that scored in between 40 and 49. And then the cumulative there would be 15. You're just adding 2 to the 13 to get a total of 15 scores that have been considered. All right, so how many scores are there between 50 and 59? All right, and then you'd count that. Scores between 50 and 59 are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19. So there are 19 scores. There are 19 people who scored between a 50 and 59. All right? 19 people. And then the cum would mean adding 19 to that. And I think that'd be 34. All right? I think that'd be 34. All right? 34 scores have been tallied up to this point. And then to complete this frequency table, what you would want to do is count the number of scores between 60 and 69. If we did that, we'd have 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. All right, so that would be 11 there. Let me make sure I counted this row properly. That was 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18. Yeah, I counted that properly. All right, so there are 11 scores in between 60 and 69. You'd add that 11 to the 34, and then you get 45. All right, and then the last thing that we would do to complete this frequency table is to count the number of scores between 70 and 79. We could do that. We get 1, 2, 3, 4, 5. All right, so there are 5 people who scored between 70 and 79. You'd add that 5 to the cumulative number of scores, and then you would get 50. All right, you get 50. Sorry about that, okay? And that would be the completion of a frequency table representing this data right here. All right, so then I'd also want my students to set up, using this frequency table, I'd want them to set up what's called a relative frequency table. And maybe we can zoom out just a bit. That's a little bit too much. All right, so a relative frequency table, keeping the same sort of headings, if you will. Let's say we got 30 to 39, 40 to 49, 50 to 59. Some people scored between 60 and 69. Some people scored between 70 and 79. All right, so a relative frequency table. A relative frequency table has to do with finding the percentages, using percentages of each of the groups. All right, so one of the things that we said here was that two people scored between 30 and 39. And what we want to do is acknowledge what percent of the total number of people who took the test, what percentage does that represent? So there are 50 people who were acknowledged as taking this test. 2 of them scored between 30 and 39. So a quick percentage there, 2 out of 50, 2 out of the 50, that represents 4%. 4% of the people who took this test scored between 30 and 39, 2 out of 50. And then you're acknowledging the overall percentage up to that point, so that would be 4% as well. We have considered 4% of the total population up to this point. And then 13, over here, 13 people scored between 40 and 49. All right, so what we're going to do is acknowledge the percentage of the people who scored between 40 and 49. That percentage would be 26%. 13 out of 50 people scored between 40 and 49. That represents 26%. And the total percentage that we would have considered up to this point would be 30%. You're adding the 26 to the 4%. 30% of the students have been tallied up to this point. All right. Then 19 students scored between 50 and 59. That represents 38% of the total students. That 19 out of the 50 represents 38%. And then you add that 38% to get the cumulative. You add that 38% to the 30 that's already been tallied. You get 68%. And then you want to figure out the percent of the people who score between 60 and 69. That would be 22%. 11 out of 50 be 22%. You add that to the 68% here. You get 90%. 90% of the people have been considered after we've counted the people who score between 60 and 69. Then finally, last but not least, five people out of the 50 scored between 70 and 79. That represents 10% of the population. That represents 10% of the population. You'd add that 10% to the 90, confirming that we've considered all 100%. All 100%. So these are called frequency tables. I'd expect my students to be able to, me producing the form, I'll produce the form, but I'll expect my students to be able to fill in these columns given data as was given similar to what we gave you here. Given this data, I'd expect my students to be able to complete both a frequency table, and then what's called a relative frequency table. All right, so that's the first topic that our students would be expected to know and understand. Sometimes when you're just dealing with numbers, though, if you've got all these numbers everywhere, it doesn't bring the kind of clarity that you might want. So now what we're going to do is we're going to take those numbers that we produced in our frequency table, and we're going to create a picture, and that picture is called a histogram. And what, you've heard the expression that a picture is worth 1,000 words. Sometimes if you got all these numbers all over the place, it doesn't bring the kind of clarity and understanding as to what is happening as far as, in this case, as far as how the students scored. So before we move to the histogram, I want to extend the invitation one more time. 312-738-1060 is a phone number here. I'd be more than happy to work with whatever topics that you'd like to discuss in the areas of mathematics, whether it be algebra, geometry, or calculus, or trigonometry, even statistics. I would love to answer whatever questions that you have to prepare you for your upcoming test or quiz, or this is final exam season. Whatever you'd like, give me a call, and I'll do the best I can to help you. All right, so let's talk about taking this information here that we have in our frequency table and creating a picture, a picture of all the data that we had, okay? All of these scores that the students, all the scores, the students, they got all these scores, okay? All this data here, and if you just throw all of this data at an individual, you may not have a real good idea you don't have a good idea of how the students may have performed relative to each other. So let's try to put all this data in a picture form and get a better idea of how students may have performed. All right, so let's zoom out just a bit. All right, zoom out just a bit. All right, so I already put together a template of how I think we should distribute this data. And what we're going to do is we're going to examine how many people scored between 30 and 39, and we want to do that in terms of this picture here. All right, it's called a histogram. All right, so how many people scored between 30 and 39? 2. So what we would do is we would extend a line up here to 2 and maybe acknowledge that region there. And what that's telling you is 2 students scored between 30 and 39. How many students scored between 40 and 49? Well, 13. 13 students scored between 40 and 49. So you'd go up to here, you'd extend this up, and you would bring that over. And now this is showing you how many people scored between 40 and 49. Okay, I hope you can see that. But hopefully you can see that a picture is clear. The picture is clear. It not only shows you how many people scored between 40 and 49, but it also shows you relative to the people who scored 30 and 39, this just shows you how many people in terms of a picture scored between 40 and 49 versus the people who scored between 30 and 39. Sometimes when you write things as a picture, it's just a little bit clearer than just having a number 13 versus a number 2. All right? How many people scored between 50 and 59? Well, it says 19. So let's extend this up to almost to the very top of our graph and then bring this down. All right, so this is the number of people who scored between 50 and 59. All right, and then the number of people who scored between 60 and 69 would be 11. That would be about right here. All right, just use a different pattern so you can See a definite difference between categories. And then the number of people who score between 70 and 79 is 5. All right, so hopefully you can see how the the frequency table really helps you organize your data, and it really helps you to draw your histogram rather easily. All right. So again, we're in this topic of statistics. We're in this topic of statistics, and we're going to keep it moving unless you call in. I really wish that we had at least one person call in today. The number 312-738-1060, and you call in with a mathematics question. Okay? If I can't help you, I'll let you know. I'll be very upfront. I can say I really can't help you with that. But I think that I would be able to help you if you were to call in. We're going to keep it moving. We're going to keep it moving and discuss something called a box whisker diagram. A box whisker diagram. And what the box whisker diagram does is it organizes the data in a different way. Again, this idea of taking a bunch of data and organizing it so that it's presented in a picture format versus just having a bunch of numbers. Sometimes this is very helpful when you're able to turn a bunch of numbers and organize those numbers into a picture. And that's what we've already done that with something that we call the histogram. But now what we're going to do is we're going to do the same thing, and we're going to organize the same data that we had, and we're going to turn it into a box whisker diagram. Let's just jump into it. All right. So, with this box whisker diagram, let's, oh, you can't see that. Sorry about that. All right, so this box whisker diagram, let's put a nice extended line like so. Okay, and what we had is we're going to organize when you're working with this box whisker diagram, it's important for you to have all of the data organized numerically from the least to the greatest. It's very important that you do that, and that's another reason why I chose to use this data right here that's organized in this way versus the data that's not really organized from the smallest to the largest. All right, so when you want to create a box whisker diagram, it's going to be very important. It's going to be very important that you understand what's called a median. The box whisker diagram is organized based on your understanding of medians. All right. So as we look at this data here, it's going to be very important that we have 50 pieces of data here. We know that because our frequency chart told us that we have 50 pieces of data. The median of this data represents the middle. All right, represents the middle of the middle term of all of this data. So because we have 50 pieces of data, the middle piece of this data would be the data that would be the 25th term. All right, the middle piece of data would be the 25th term. All right, so what you would do, you know, if you have, let's talk about median before we get started. If you have a number like 1, 3, and 5, we're just talking about what is a median, because if you don't know what a median is, you can't really produce this box whisker diagram. So the median term here would be the middle term. Here the median, the middle of these three numbers would be 3. So the median would be 3. All right. So what you could do is you could, if you had so many numbers that you couldn't really figure out what the middle number is, you would take how many terms you have. In this case, it's 3. You could add 1 to that, divide by 2. If you come to the understanding you have 3 terms, if you add by 1, you get 4. You divide that by 2, that would give you 2, and that would tell you which term represents your median. If that was not clear, let me do another example. And hopefully I can make that clear. All right. So if you had, let's say, a 1, a 2, a 3, and a 5, all right, and a 5. And you wanted to know the median of those numbers. You wanted to know the median of these numbers. Here you can see that there's no physical middle number. You've got 4 numbers. When you have an even number of terms, there is no physical middle. So what you could do here is observe that, maybe acknowledge that there will be 2 middles, if you will. All right, so acknowledge the average or the mean of the 2 middle terms. In this case, you could see that there are 2 middles, and what you would do is you would take the average of each of these middle terms. As you take the average of the 2 and the 3. So here, the median for this data here would be 3, and the median of this data here, when we had an even number of terms, would be 2.5. 2.5. All right. So that said, let's find a bunch of medians using this data that we have right here. Notice that we have a lot of data. All right, so we want to figure out the middle of all of this data. We want to figure out the middle term in all this data. We've got 50 pieces of data. So what we could do here is we could realize that if we've got 50 pieces of data, the actual middle, if we've got 50 pieces of data, the actual middle would be taking, if we took 51, let's say, if we took 51, excuse me, let me put this in, take 51, divide by 2, all right, you are going to end up with roughly 25.5. You took 51, let me show you what I'm doing here. You take, you have 50 terms, you have 50 terms, you add 1, all right, and then you divide by 2. That's going to tell you that you're going to get roughly 26 terms, 25.5, but let's round that to 26. So roughly the 26th term would actually represent your middle term, your 26th term. And what you could do now is just count 26 terms. So this is the smallest. It's the second term, third, fourth, fifth, sixth, seventh, eighth, ninth, 10th, 11th, 12th, 13th, 14th, 15th, 16th, 17th, 18th, 19th, 20th, 21, 22, 23, 24, 25, 26. This 3 here, which is in the row of 5, represents the 26th term. You could even count from, maybe count backwards if you like. This is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, so this is the 20, this term here, this would represent, this would represent the 25th term coming from the top. This would represent the 25th term coming from the bottom. So really what you're going to have to do here is you want the middle term. You want the middle term. So to get the middle term, you'd have to take the average of these two terms here to get what we call the median. So this would be the average of 52 and 53, which would be 52.5. So the overall median of all this data would be 52.5. And that would be how we'd start our box whisker diagram. This would be the median of all of the data. The median of all of the data of each one of these scores would be 52.5. All right? So now what we want to do is find the median of the upper half of the data and then the median of the lower half. All right? So the median of the upper half of this data is going to come about from these 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25. All right, so these 25 terms represent the data that would constitute the upper half of all of this data. And what we want to do is we want to find the median of this data, which is the upper half. So if you have 25 pieces of data, when you have an even number, you can take that 25, add 1, 26, divide by 2 to get 13, and the 13th piece of data would represent your median. So let's go, let's take this upper half, let's count 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. This is the 13th piece of data in the upper half. Let's also count downwards, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, so this 3 here, which is in the row of the scores that were 60, that represents the median of the upper half. So what we're going to do is go to our box whisker diagram. That's 52. Let's sort of count. Let's just sort of. I should have done this ahead of time. Let me just fill out this chart a little bit. All right, so let's say this is 54, 56, Let's say that's 56. Let's say that's 58. Let's say this is 60, 62, 64. All right. So we said that our median of the upper half would be 63. So let's put a line right here at about 63. Let's put a line right here, which came from our median of the total amount of data. And now what we'll need is the median of the lower half, which is the lower half would be the scores lower than the overall median of the data. So again, we're looking for that 13th term. We got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. The median of the lower half would be the score 48. All right, so let's acknowledge that over here. So let's call that 50. Let's call this 50. Let's call this 48. All right, so that would be our median of our lower half, about right there. All right. So again, we counted 13. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. All right, this 8 here represents the middle piece of data in this lower half of the data that we're looking at. We counted 13 from above and then 13 from below. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So the box whisker diagram, what you're going to do now is connect these medians, all right? And then what you're going to do is acknowledge the highest piece of data, which in this case is 79. You're going to acknowledge that with something called a whisker. Let's label this a little bit more. You got 66, 68. Maybe you have to extend this a little bit more. Let's call this 70, 72, 74. Sorry about that. Let's get this out of the way. I was just trying to explain to you what a median was over here. We don't need that anymore. 76, 78, and then 79 would be about here somewhere. So you'd extend this out to the highest piece of data, and you want to also acknowledge the lowest piece of data, which as you can see is a 32. And rather than number this completely, what I'll do is I'll just acknowledge that 32 would be somewhere here, about, okay, and we would extend this lower extreme, and they're calling that a whisker. What this diagram does, let's try to make it so you can see all of it. What this is doing is breaking the data into quarters. All right, in fact, they call these quartiles. All right, the first quartile. All right, so this is a quarter of your data. Here, this represents a quarter of your data. This is another quarter of your data, and this is another quarter of your data. Again, it's just trying to take all of this data and write it in terms of a picture. All right, so again, a quarter of your data, 1/4 of this data, 1/4 of this data is in between 32 and 48. All right, another quarter of this data is in between. I'm not sure if you can see it. Another quarter of this data is in between 48 and 52. So there are a lot of scores, 25% of the scores approximately, in between 48 and 52. Another quarter of our data is in between 52.5 and 63. All right, so another 25% of our data is in between 52.5 and 63, and then the final quarter of our data is in between 63 and 78. So again, a picture sometimes helps as opposed to just putting numbers on a paper. Sometimes if you can turn the numbers into some kind of picture, this really brings clarity. Speaking of clarity, I'd like to bring some clarity to the problems that hopefully you would have on an upcoming test, quiz, or something like that. I'd love to answer whatever questions you have. If you call the number 312-738-1060, I would do the best that I can to answer whatever questions that you have. In the meantime, I've got a lot to discuss. I'd like to discuss a topic that will also be on our pre-calculus assessment, our final exam, and that's a topic called standard deviation. Standard deviation. I want my students to understand what standard deviation means. All right, so let's look at an example that I created. You've got two classes. All right, you've got one class that they scored their class average, hopefully you can see, is 80%. The class average is 80%. If you average these scores, 81, 80, and 79, that average would be 80%. And then if you found the class average here for the second class, that class would be 80%. All right, let's say I'm a teacher, I have to report to my supervisor. I say, hey, my class average was 80%. But hopefully you understand that additional information could bring clarity. Could bring clarity to this idea of the class average being 80%. Hopefully you see that 80% doesn't tell the whole picture. Because this class average was 80. But this class average was 80% as well. Both classes average 80. So I would have to present to my supervisor, I would have to present to them something more than, hey, my class average was 80 to bring greater clarity. That additional information that would need to be contributed would be this idea of standard deviation. All right, so the way you calculate standard deviation is with an equation. Let's use a variable s. The way you calculate standard deviation is with an equation where they'll want you to take the summation of, let's just say, x minus x bar. This, it'll be clear in a second what that means. Let's square that and let's divide by n. All right, let's divide by n, and what we're going to do is we're going to take the square root of all of that. And with that, you're going to be able to find the standard deviation. Now, I would like my students to not only understand this formula, and we'll bring clarity to this in a moment, but I'd also would like them to know how to put this into their calculator, just simply put these scores in the calculator and have the calculator calculate the standard deviation automatically. All right, so what this X means is this X means acknowledge each individual score. All right, what this X bar means is what is the standard, the mean. Sorry about that. This X bar represents the mean. This variable n represents the number of pieces of data, and I think we all know what squared means. And the square root, or actually this summation symbol, that is that's a symbol that tells you to add these square differences. All right. So sometimes, rather than trying to explain it, it makes it clear if I just actually found the standard deviation up front. All right. So what we're going to do is take each individual score, 81, and subtract. I'm going to take 81, subtract the mean. I'm going to take 80, subtract the mean, and I'm going to take 79, subtract the mean. All right, so if I did that, I'd take 81 minus 80. I'm going to square that. I'm going to add the second score, which is 80 minus the mean. I'm going to square that. I'm just following what this equation is telling me to do. And then I'm going to add the 79. I'm going to subtract the mean, which was 80, and I'm going to square that. I'm going to divide all of that by the number of scores. Divide all that by the number of scores. That's what n represents, which is 3. I'm going to put all that in the calculator, and it's going to give us a standard deviation. Let's do the same thing for, well, actually, let's go ahead and calculate this out. So 81 minus 80, that's 1. I'm going to square that. 80 minus 80, that's 0. I'm going to square that. And then 79 minus 80, that's negative 1. And I'm going to square that. All right. So if I did that, I'm going to, and divide all that by 3. That's the number of scores. And you end up with the square root of 1 plus 1 over 3. You're going to end up with the square root of 2 divided by 3. And I'm going to put that in my calculator. We end up with the, I need the square root feature. There we go. So I'm going to take the square root, I'm just putting it in the calculator, of 2 divided by 3, and I get 0.81. Let's just round that to 0.8. We'll talk about what that means in a minute. The standard deviation, the mean of this class was 80% with a standard deviation of 0.8. We're going to talk about what that means in a minute. All right, let's find the standard deviation of the second class. I don't have a lot of space. What I'll do is I'll show the work right in this area right here. I'm going to use the same equation. I got the square root, a summation of x minus x bar. I'm going to square it, divide by the number of pieces of data. I'm going to do the same thing that I did over here. All right, but I'm going to consider each score. So we got the standard deviation is equal to the square root, excuse me, 70 minus the mean. Again, the mean was 80%. 70 minus 80, I'm going to square that. and then I'll add the second score, which was 80. 80 minus the mean of 80. I'm going to square that. And then I'm going to add 90 minus the mean, which was 80. I'm going to square that. I'm going to divide it all by the number of scores. All right? And after doing that, what we end up with, and sorry I'm running out of space a little bit here, I'm going to end up with the square root of, that's going to be negative 10 squared plus, this would be 0 squared, and then 90 minus 80, that would be 10 squared. I'm going to divide all that by 3. Again, my students would be expected just to be able to put this in a calculator and get this without doing it by hand. But I still want them to understand what the calculator's doing to yield the answer quickly. So you square the negative 10, you get 100. You square the 10, you get 100 again. Divide by 3, and you're going to end up taking the square root of 200 divided by 3. Let's do that. Let's put that in the calculator. All right. Put that in the calculator, and you get the square root of 200. Let's divide 3, and you end up with 8.2. 8.2. So the this standard deviation 8.2. So here, one class, I'll put in parentheses the standard deviation. The standard deviation is 8.2. The mean was 80%. The standard deviation was 8.2. Here, the first class, the mean was 80%, and the standard deviation was 0.8. 0.8. If I am a teacher and I say to a supervisor, the class average was 80, and the standard deviation is big, what that means is there is a significant range of data that surrounds the mean. That means that if the standard deviation is big, that means that there's data that's significantly higher and significantly lower than the mean. If I am a teacher and I go to a supervisor and I have a mean of 80 and the standard deviation is very, very small, what that means, you're to interpret that in a way where the mean is, let's say, 80, but there is not a significant gap above and below the mean. The amount of data that surrounds the mean is not a significant gap. The amount of data is not a wide range of data above and below the mean. If the standard deviation is small, if the standard deviation is big, there is a big gap between the data above and below the mean. Let me try to be as clear as I can in the next minute that I have, because my time is about up. What we would do is we would take the 80%, and if we were to even round this standard deviation to 8, you would go above one standard deviation from 80 and below one standard deviation from 80. And if we round the standard deviation to 8, we would add 8 to the 80. If we wanted to be more accurate, you would add the 8.2. But if we would add 8 to 80, we would get 88. And if we would subtract 8 from the 80, you subtract 8 from that, you would get 72. So what that means is that most of your data is within plus or minus 1 standard deviation, and most of your data would be between 72 and 88. But I'm sorry we ran short on time. I'm really, really sorry that I got a little bit long-winded. That's all we have time for. God bless you. When you're in your classes, put forth your best effort. Never quit.